All right, we are looking at the features of a circle from its graph. What are they asking for? What is the center of the circle? All right, well, let's just go in order here. It looks like there's another question too. Yeah, so let's just first focus on the center. Here's our circle here. So the center is an equal distance from all the edges. A lot of times you can just eyeball it on these. So just kind of be careful on that. So in this case, it's 1, 2, 3, 4, 5, 6 across. So that's one way you can do it, is from one side to the other and then just divide by 2, which is 3. 6 divided by 2 is 3. So it's 1, 2, 3 blocks in. So there's our center right there. That's at, we do x first, -6 and 4, -6, 4. Is that one of our answers? Yes, it is, -6, 4. All right. And then what is the radius? All right. So there, the circle passes through what? The point, -3, 5. What is the radius? Radius is the distance from the center. So they're kind of setting you up with the parts that you need here. So the center is -6, 4. And it passes through this point, -3, 5. So what is the radius? So we're just going to go ahead and jump right on the distance formula. So this is the distance is equal to the square root of the change in y's, y2 minus y1, quantity squared, plus the change in x, x2 minus x1, quantity squared, and all of this, make sure it's all under the square root sign. And if you forget, you can always just go ahead and draw this and make like a right triangle and do the Pythagorean theorem. The distance formula is the same thing as the Pythagorean theorem. It's just jumped right to the answer that we need. All right, so plugging in the parts that we need. Doesn't matter which one's which. I just like marking everything. So I'll call this my x1. This is my first point, y1. And I'll call this my second point, x2, y2. That way I can plug everything in without getting them confused. All right, so all of this implies that the distance, or the radius in this case, but the distance from the center to any outside point would be the radius, is equal to the square root of y2 minus y1. y2 is 5 minus y1 is 4. All of that gets squared. I lost my square root sign there. Plus the change in x's. x2 is -3. And minus x1. x1 is -6. It's a double negative sign. Now, one of the good things, and it's real important to kind of remember this, that when we label these, it's really important that we don't mix up the 2's and the 1's. So change is defined as the second minus the first. But if you do the first minus the second, it's not too bad because you're squaring it anyway. But you cannot change it around. So it's real important. Just practice proper form. So just have the second one come first, however you deal it. Just sort of notice that if I had labeled this the second point and this the first point, that it kind of pops out the same answer. So that's not going to be a problem. Just make sure it's organized well. That's why it's so important to label. All right, so we're just going to simplify now. Order of operations, do what's inside the parentheses. 5 minus 4 is uno, or 1. And that gets squared, plus -3 minus a -6. Well, a negative and a negative make a positive. So that's going to be -3 plus 6, which is +3 squared. Now, I didn't have a parenthesis here, but if it was negative, I would definitely be required to have a parenthesis here. So let's just go ahead and put it there anyway. I don't need it, but let's make it perfect. All right, and then our distance is now equal to, we'll simplify. 1 times 1 is 1, plus 3 times 3 is 9. And all of this turns into the square root of 1 plus 9 is 10. 10 is 2 times 5. There's no pairs in here or perfect square numbers, meaning this is our final answer. And there it is right there, square root of 10. Okay. See if there's anything else going on here. Let's see. Just be careful about counting on this. Notice that they don't go exactly on the grid, so just be careful with that. That's why you definitely need the distance formula going with these. I just didn't even worry about the graph, just straight into the distance formula. That's the most consistent way, but just if everything's easy on the graph, then that's not a problem too by observation. Okay, let's see what we got next. All right, what is the center of the circle? It passes through this point. What's the radius? And it looks like everything is exactly the same kind of problem. Good luck.